All right. Thank you, everybody, for coming. I'm James Thorne, and we're going to be talking about telco OpenStack use cases. I'm a cloud solutions architect at Rackspace. I've been there for 2 years. Today, I'm going to be talking about Rackspace's experience working with telcos, what they're interested in getting out of OpenStack, why they want it, and some of the challenges they face in adopting it. And I'm by no means new to OpenStack, but what I am new to is telcos and those interested in OpenStack. And I've spent the last month talking to Rackspace employees, reading blog posts, watching former videos from the OpenStack Summit to figure out how all these things fit together. And what I've discovered is that kind of that world of telcos wanting OpenStack is just as complicated as OpenStack in and of itself. And this presentation is very much a newcomer's view into this. So for any of you that currently work in the telco space or heavily invested in OpenStack, if you have any input, feel free to give it at the end of the presentation during the Q&A piece. All right, so quick audience OpenStack familiarity. This seems to be a theme today with all the speaking sessions. Anybody new here anybody just getting started with OpenStack here? No? Good? All right. Who here works for a telco? One? We got one at least.
Directly or indirectly?
Both. So that works. All right, we got a few more. For those indirectly or directly working for a telco, are you just getting started with OpenStack? No? So you have been using OpenStack? Some capacity? All right, very good.
Again, I don't know, you didn't hear my talk, but telcos have long time frames for bringing things.
Sure.
So,
Yeah, that's what I'll touch on today too, so a bit of that, as I'm sure you're aware. So, all right, a quick pulse check on OpenStack. It's 5 years old. 5 years young is probably a better way to say it. And its growth has been nothing short of phenomenal over those past 5 years. You kind of have the growth of Linux, which took X amount of time. The growth of OpenStack is now happening in this amount of time. And things are happening so quickly. And you hear of hockey stick-like growth in the stock market, unfortunately not recently. And OpenStack has kind of followed that same trend. We've been going like this for a while, and we're on that bend, and it's about to skyrocket up the rest of that stick. And I think a large part of that has been because of enterprise adoption and telco adoption. And enterprises are finally starting to adopt OpenStack. And when I joined Rackspace, I was mostly talking to small to mid-sized companies, and now more and more I'm talking to enterprise companies, of which include telcos. And as mentioned, or to be mentioned, I believe a large part of this increased adoption has been because of a few things that the OpenStack community has focused on. Reliability, stability, and upgradability. And we saw quite a bit of that talked about today earlier. Beginning with OpenStack Icehouse, the community really started focusing on these three things. They started introducing code that made upgrades much easier or had little to no downtime. You could upgrade the compute plane while having an older control plane, and then once that was upgraded and looked good, you could then upgrade that control plane and you're on a new version of OpenStack. And as the releases have happened, that's gotten better. We're now on the latest release is Kilo. Liberty is just around the corner later this year, and those three things are getting better and better. And reliability and stability are kind of a given for any platform adoption, especially in the enterprise space. They have to have that stability and reliability before they want to actually run it. And what really matters to enterprises is that upgrade cycle. And as you all know, the OpenStack upgrade cycle or release cycle is 6 months. Enterprises don't do that. They never have. And it's kind of questioned, or it remains in question if they will do that in the future. But being able to upgrade a platform such as this in a reliable manner with little to no downtime will help spur more adoption from enterprises in that regard. So some characteristics of a telco. These are, of course, not everything. These are a few that I really discovered as I was researching this presentation. First is control. They want to control the entire stack from hardware to software. And even though they want to do that, they still need to lean on some vendor. They have that single vendor relationship. They want to be able to pick up the phone. I just heard it in the previous session. They want that one throat to choke. And they want to be able to have pro-serve engagements when they need them. And as I just said, single vendor relationships, that's kind of the traditional thing with telcos. And of course, a telco is not going to have one vendor for the entire company. It may be one vendor for maybe a particular infrastructure stack. Maybe that's the SMS infrastructure or something. And then other stacks within the company would have some other vendor that provides the hardware and software, and it's probably a combination of both. And because they have that single vendor relationship and they have that specialized hardware and that specialized software, it makes it very difficult for them to innovate here. It makes it very difficult for them to move quickly and change things, and that goes into the iteration characteristic. Telcos don't upgrade every 6 months, every year, every 2 years. It's probably every 5 to 10 years, and it just depends on the particular stack that they're running. And now we get into why do telcos want OpenStack? And I found there's two big reasons. There are, of course, more, but these were kind of the two that stood out the most. The first one is the same reason everybody else does. They want to become internal and external service. They want to become a service provider for their internal and external customers. And telcos and enterprises alike, they're tired of it taking days to weeks to get resources provisioned, whether that's compute, network, or storage, kind of those three core resources that you need to do anything. It's ridiculous that it takes that long to get anything provisioned. So because it's taken this long, developers or whomever else in the organization that have deadlines to meet, they're going to go somewhere else. They're going to take the path of least resistance. They're going to go to Amazon. They're going to go to Rackspace. They're going to go to Google and use their public clouds, and you get shadow IT out of that. And that's bad for a whole host of reasons. Security and intellectual property reasons are just two. In addition to that, telco and enterprise IT departments, they need to offer cloud platforms within their physical walls and within their firewalls, and OpenStack can provide that. It's kind of, VMware has kind of been that traditional thing, but it's with VMware platforms that telcos and enterprises take days to weeks to get something provisioned, which is a bit ridiculous in my eyes. I've been a VMware admin, and I know what it takes to get provisions created, so they could definitely implement processes there to increase that, but you get the whole cloud stuff coming. OpenStack can be that platform for these enterprises. And not only will OpenStack allow those IT departments to have cloud resources inside their physical and virtual firewalls, those managing that platform suddenly have a standard platform they can run everything else on. Whether that's internal customers using it for a development pipeline or internal tools, or maybe external customers accessing a company's public-facing website or public-facing portals or applications, or if the particular telco or enterprise is actually a service provider, then external customers will use that platform to provision compute, network, and storage resources. So why is it that telcos want this? Why do they want this, but why do they need it? And again, just like everybody else, they have to iterate faster. In today's world, if you can't iterate quickly and get your product to market, you're going to be left behind. And a good example of that is SMS. SMS revenues have been down drastically over the past few years. Why is that? Well, people aren't sending traditional text messages anymore. They're using Apple Messages. They're using WhatsApp. And those things have been a boon to consumers because they work globally, they're more featureful, and they cost practically nothing. And there is a cool factor associated with that can spur a whole nother conversation in and of itself. So if that SMS infrastructure was tied to a particular vendor, then they can't really iterate the hardware, they can't iterate the software. What they need is a standard platform where they can take whatever functions it takes to implement that SMS infrastructure and run it on top of a standard platform. And OpenStack can be that platform. So they're going to take those physical network functions and then turn them into virtual network functions. And with that, we get into a whole nother world in the second use case of acronym soup. And this is kind of the second use case that telcos are interested in OpenStack for. So PNF, VNF, NFV, SRIOV, and DPDK. And this is probably not even all the acronyms that go along with this. These were a lot of the ones that jumped out in everything I watched and read and talked to anybody at Rackspace about. And I'm just going to briefly touch on each of these. Going deep into these would require its own 45-minute presentation, and being between you all having happy hour to go to, we'll all fall asleep if you listen to me drone on about that. So physical network function is kind of the current legacy way of doing things. Telcos go to a vendor, they purchase specialized hardware. Maybe it's a load balancer for SIP traffic or something like that. Virtual network function is virtualizing those specific functions that physical hardware did in software. And instead of the vendor or the telco going to that particular vendor, they go purchase commodity servers, commodity load balancers, commodity switches, routers, whatever, and then take that particular function and run it on top of that in software. And then network function virtualization. So those two words, virtual network function and network function virtualization, they look like they're just rearranging of the words. Virtual network function is, as stated, virtualizing those specific components. Network function virtualization is more of a concept. It's the network architecture concept of virtualizing an entire network functionality into a way you can build virtual network functions with building blocks. So the load balancing piece may be a block, and then the routing may be a block, a WAN accelerator may be a block, and then with all those blocks, you can then begin to structure something together to make a communication service. So you're going to hear the term service chaining. That's chaining all those things together into a service. So the next two things are less concepts and more specific things that enable these concepts. SRIOV, single root IO virtualization, that's a mouthful in and of itself, but essentially it provides virtual machines direct access to an Ethernet port. So there are particular NICs, such as the Intel X560, that offer 32 raw channels that they can allocate to VMs. So maybe you have 32 VMs, each VM can have their own channel, and on that channel you can run whatever protocol stack you want, whether that's TCP, UDP, a SIP stack, or whatever sort of stacks or protocols telcos will need to run. Scott Lowe has a fantastic blog, and in his blog he has a post titled "What is SRIOV?" and it was actually written back in 2009. So clearly, a lot of these things have been around for a while, and I think they're starting to really spur up in the OpenStack community because telcos and enterprises that have to deal with this stuff are suddenly wanting a standard platform. So we're getting all that stuff that's existed for a while coming into the ecosystem to be worked on. And lastly, Data Plane Development Kit. It's essentially a set of data plane libraries and network interface drivers. So it's a programming framework. And it allows anybody who's programming for a particular NIC card to eke out as much performance as possible out of that commodity gear, if you will. I ran across several scenarios where telcos were working with a single vendor and they hit the performance limits of a particular device. Maybe that's because they scaled the device up as far as it could go and they couldn't, I don't know, add another one to kind of horizontally scale that, but they hit certain limitations there. So if they can take commodity gear and have these frameworks to program on top of them, they may be able to eke out even more, and if they can horizontally scale that, then they get around that issue where you hit that scale up limit. So how do all these work together? And I need to be able to visualize something in my head for me to understand it, and this is what I came up with. And most things in IT can be stacked. So at the bottom, you have OpenStack. Underneath OpenStack, which isn't shown here, you'll of course have the hardware, and in that hardware you'll have NICs compatible with SRIOV, maybe using the DPDK step to program on top of those NICs. But moving up it, you have SDN, so the ability to programmatically define those networks. That could be standard Neutron, that could be Plum Grid, that could be a Conda, that could be Open Daylight, whatever you want to use there. And then moving up, you have virtual network function, which create those building blocks to create your NFV infrastructure, and then NFV at the very top, network function virtualization, to kind of form that concept of stringing all these things together and creating an actual service out of it. You could probably put VNF and NFV somewhat on the same level. It may not make sense to have them on top of each other. I've seen situations and architectures where the SDN component is removed completely, and the NFV and VNF blocks are just kind of running on their own. So earlier there's probably been architecture talks that discussed that, and that may be a factor there. So all these things are things that most of us don't have to worry about, and telcos want to be able to run this on top of a standard platform. So why haven't telcos adopted this standard platform more quickly? What have been some of the barriers in the way of it? So again, we come back to reliability, stability, and upgradability. Every time we make a phone call or send a text message, we expect it to work, and we all know that doesn't happen 100% of the time, but it happens enough to kind of, I guess, call it carrier grade, if you will, and there's all sorts of factors why we have issues that we do now. And telcos are not going to rush into something that doesn't have these three things. They have to make sure it's carrier grade. And as mentioned earlier, OpenStack Icehouse and the subsequent releases are making sure each of these three tenets are at the core foundation of the code, and it's always getting better. Unwillingness to contribute to open source. So telcos have a lot of intellectual property. It's a tough industry, and they're not going to give a competitive edge to anybody else in the industry. And unfortunately, when you have those sorts of things kind of baked into your DNA, that doesn't allow you to, not allow you, but that keeps them from contributing to any sort of open source in general. And they're slowly kind of warming up to this. It's going to take time. It's going to take big names to really start pushing stuff out and showing, hey, we pushed this out. Maybe someone else will come and follow. It's kind of an organic cycle that needs to happen for everybody to get on board with it. And I think as more people do it, the other names or the other big telcos and enterprises will come into play as well. The pace is too fast. So Telcos are used to iterating every 5 to 10 years, as mentioned. How can something that moves this quickly every 6 months be reliable? And that somewhat goes back to the unwillingness to contribute to open source. I think there's been that fear, uncertainty, and doubt about open source and enterprises, and that how can this be reliable? This isn't from a big name company with billions of dollars in market cap. How can this possibly work? And I think over time, again, organically, that'll kind of go away as companies that are enterprises, telcos, or not, come out publicly and say, yeah, we're running our entire business on top of OpenStack, and it's obviously working, and we're a stable company with revenue coming in. They'll start to kind of open their eyes to things like that. Yeah, so moving on. So content-wise, that's all I really have for you today. I really rushed through that given the time constraints. I wanted to quickly run through the references I used when researching this. Supporting telecom and NFV with the open source ecosystem. This is from John Zanos and Tobias Ford from Canonical and AT&T. This was presented at the Paris OpenStack Summit. It's always interesting to have a popular Linux vendor and a popular telco come together and work on something like this that alone breaks down a lot of barriers that traditionally you wouldn't see happen. These slides will be put up online for you to grab the link if you need it. You can also Google that and you'll be able to find it. Another Paris OpenStack talk, NFV and Telco Solutions on OpenStack by Martin Ectors and crew. There was other people in the presentation that weren't mentioned by name, but he was with Ericsson. Canonical was also there, and they delve into some of the newer companies like WhatsApp, how they work, how they function, why they're able to have 30 engineers and support hundreds of millions of users as well. Lastly, as mentioned, Scott Lowe, what is SRIOV? You can just Google that and you'll find it. He is a very popular blogger. And then this time, last one, NFV, VNF, and Deterministic Architecture, What Does It Mean? By Nick Chase with Morantis. This was a great article to really pull all this stuff together and kind of solidify everything. And what's not up here, the Wikipedia article for NFV was extremely informative. Even after viewing all these things, it's still kind of confusing how it all works together. The Wikipedia page really helped bring it all together. And one last question, and this is more for audience participation and any additional info. For any of you working for a telco, was there anything covered here today that you're using OpenStack, or was there anything you're using OpenStack for today that was not covered here today? So any of you three pretty much.
Check my pocket.
So, okay. All right, Q&A. Any questions? Good. I know we all want drinks and want to get out of here. So, cool. All right, thanks. I'm James Thorne. Check if you want to get in contact with me. I'm J Thorne on Freenode, James W. Thorne on Twitter, and I blog at thornelabs.net. So thank you, and enjoy the rest of your evening.